Hello, my dear students, and welcome back. I know, your exams are just around the corner and the tension is building up, but don't you worry. Today, we are going to crack the secret code of a really important geography chapter, map scale. And I promise you, by the end of this, it's going to feel super, super easy. So let's get started. Okay, let's start with a little bit of a puzzle. Have you ever thought about it? How can you possibly hold the entire country of India, all the way from Kashmir to Kanyakumari, right in the palm of your hand? Or how does Google Maps squeeze the whole world onto your tiny phone screen? What kind of magic is this? Well, guess what? It's not magic. It's the amazing work of cartographers, the people who make maps, and they use a very special secret code. You see, if you just draw a place, say the route from your house to your school, without any proper measurements, it's just a drawing. In geography, we actually call that a sketch. It's nice, but it's not very useful for measuring anything. But the moment you add that secret code, poof, that drawing transforms into a real, proper map. And that secret code, my friends, is what we call the scale. So, let's dive deep into this secret code. The scale is probably the single most important thing on any map. It's the key that unlocks all the real information the map is trying to tell you. So, what exactly is a scale? Well, in the simplest words, it's just a ratio. It's the connection between a distance you measure on the map, let's say with your ruler, and the actual distance on the real ground. Map distance versus ground distance. That's it. Simple, right? Now, to show this relationship, map makers use 3 different methods. Let's think of them as 3 different heroes who help us write and understand our secret code. First up, we have the statement of scale. This hero is very direct, very straightforward. It just tells you the scale in plain and simple words, like 1 centimeter on the map represents 10 kilometers on the ground. Super easy to understand. But it does have a small weakness. If you zoom in or zoom out on a digital map, that statement becomes wrong because the map size changed. Next up is the graphical scale, which you might also hear called a bar scale. Now this one is tough and super reliable. It's basically a line drawn on the map, divided up just like a ruler. And here's its special power. If you make the map bigger or smaller, the graphical scale changes size right along with it, so it always stays correct. Very dependable. And finally, let's meet the most powerful hero of them all, the representative fraction, or RF for short. You'll see it written as a ratio, something like 1 is to 50,000. Now, why is this one a superhero? Because it has no units. It's universal. Anyone, anywhere in the world can use it and understand it, no matter what measurement system they're used to. We're going to spend a little more time with our superhero, RF, because this is the one that is most important for your exams. So pay close attention now, okay? So when you see an RF, like 1 is to 50,000, like you see here, it simply means that 1 unit on the map represents 50,000 of the exact same units on the ground. The first number, the 1, that's our numerator. That's your map distance. The second number, the 50,000, is the denominator, and that's the ground distance. And the RF superpower, like I said, is that it's unitless. That 1 unit could be 1 centimeter, or it could be 1 inch. It works perfectly with the metric system that we use here in India, kilometers, meters, centimeters. And it works just as well with the English system that's used in countries like the US, miles, furlongs, inches. It's like a universal language for maps.
Okay, bachcho, now this is the part you really need to focus on for your exam questions. I call it the conversion mission. They love to ask you to convert a statement scale to an RF and an RF back to a statement scale. But hey, tension nahi lene ka. Don't worry, we are going to master this together, right here, right now.
Okay, let's take an example. Let's convert 1 inch represents 4 miles into an RF. The first rule is we need to make the units the same on both sides. So let's convert those miles into inches. Now, we know that 1 mile has 63,360 inches. So 4 miles will be 4 times that, which gives us 253,440 inches. So now our statement is 1 inch represents 253,440 inches. And because the units now match, the RF is simply 1 is to 253,440. Shabash, you did it. All right, let's go the other way now. Let's convert an RF of 1 is to 100,000 into a statement in kilometers. So this RF is telling us 1 centimeter on the map equals 100,000 centimeters on the ground. Now, you just need to remember, how many centimeters are in 1 kilometer? Yes, 1,00,000, 100,000. So to convert the ground distance, we just divide 100,000 centimeters by 100,000, and we get 1 kilometer. So what's our answer? 1 centimeter represents 1 kilometer. See? Easy peasy. Wow, you are doing so well. I think you are totally ready to test your new knowledge. Let's try a couple of quick exam-style questions just to build up that confidence. You ready for this? Here's our first question, and this is straight from your textbook. Which one of the following methods of scale is a universal method? Is it A, simple statement, B, representative fraction, or C, graphical scale? Think about which one of our heroes works anywhere in the world. And the correct answer is, of course, it's B, representative fraction. Why? Because the RF is universal. It's a pure ratio. It doesn't use words like kilometer or mile, so anyone, anywhere in the world can understand exactly what it means. Okay, next question for you. The numerator in a scale, that's the number on top, or the one that comes first, what does it represent? Is it ground distance, map distance, or both distances? The correct answer is B, map distance. Just remember this simple formula in your head. RF equals map distance divided by ground distance. The numerator, that top number, which is almost always 1, is always the distance on your map. And look at this. This is a graphical scale right out of your book. Just a few minutes ago, this might have looked a little confusing, right? But now you are a pro. You can see the RF is 1:50,000. You can see the primary divisions to the right of the 0 mark are in kilometers, and the secondary divisions to the left are in meters. You can now look at any map and read it with total confidence. And just like that, you have gained a new superpower for your geography studies. From now on, you can look at any map and truly understand the real size and distance of everything it represents. So let's do a super quick recap. Scale is the secret code that turns a simple sketch into a useful map. We met our 3 heroes, the simple statement scale, the tough and reliable graphical scale, and our universal superhero, the RF, which is the best for all our calculations. And the best part is, you now know exactly how to convert between them. You have all done a fantastic job today, seriously. So I have a question for you. What other secret codes or tricky topics in geography do you want me to help you crack next? You just let me know in the comments below, and I'll make sure to create an explainer on it just for you. That's all for today, my dear students. Study well, always stay curious, and all the very, very best for your exams. You have officially cracked the code of map scale, and I just know you are going to do wonderfully. Don't forget to hit the like button, share this with all your classmates, and of course, subscribe for more chapters made easy. Bye for now.